Hi everyone. Today I want to talk about the ProtoPart software. This is a software for the SafFire 3D printer. I'm going to talk about the menu items first. One thing to keep in mind is that the SafFire is also a laser engraving system. So there are some menu items for that, specifically the laser menu, as well as new image. So I'm not going to be talking about those. Unless you want to do laser engraving, they're probably not something that you'll need. So one of the items that you could use for 3D printing is new extrusion. I use this to make the octagon. The octagon is just a 2D PNG image. See, it's 320 by 320. And you can just copy that upwards, and you can have yourself a full octagon without doing any 3D drawing. There's also the new 3D print command, which we'll be using quite a bit. This will load SVG files from Slicer. I'm also working on Mesh Mixer. That might be an option in the future, possibly. It'll also open SLC files, possibly from JewelCAD. This is a Marvin I sliced at 75 microns. You load the STL into Slicer, and then you can make an SVG out of that. You load it in here. Usually I just say OK 3 times of these, scale factor, do whatever you want, slice height. That'll be determined by Slicer usually, and you can correct it if you want. But this will be the XY voxel size. I usually use cubic voxels. So I recommend just pressing OK 3 times when it asks for those questions. So if you want to scroll through the print, you can do that with the arrow keys. I'm pressing the up arrow key now. Just goes one layer at a time. And you can see it started at the feet. It's going for some eyes there. And it finally ends at the hook. And if you want to go a little bit faster, you can use page up and page down. That was the page down key. That's basics of using that command. There's some settings commands as well. You could open some settings if you want. There's a few there. I'm going to talk a little bit more about those later and how to use all these. But the upshot is you can pretty much save an entire print and send it to someone else with a SafFire and have them reproduce it if they have the same resin and if they have the same resin height. So there's a printer control. Printer control is one of the main dialogues that you'll use to do printing. So you'll have the run job command. Now I don't have that enabled because I don't have a printer connected now, and I also haven't run the plate level command. I'll be talking about more of the details in here. Some of the basics are just adjustments, position, rotation, basic things like that. You just want to adjust the position if you try to prevent the pieces from falling through the build plate holes. Some of the things will have little, maybe you have a support there and you don't want it to fall through the hole. Just move it and turn it till it aligns right. But I'll be talking about more of those later. Printer settings, again, talking about these later as well. There's a lot here to absorb, so I have a whole segment on that. Just a lot of commands to absorb. But that's one that you'll be using quite a bit, probably. Recalculate, I'll have another segment on that as well. You saw that happen when I did the new 3D print. So right now it's just doing measuring. If you do abort, you can go back and actually finish what it was doing. But it will also, if you abort it here, if you run printer control, it will do that. You can abort it there, you can go out and recalculate again. So it just does it if it needs to. If you do recalculate again, it won't do anything. It doesn't need to. There's array part. You can do a little array here. Usually I do a little bit more than the minimum. And of course it needs to remeasure. And then you can scroll through. Now you have two Marvins. Now it doesn't save this anywhere, it's just in memory. But you can save it with save settings. But if you do new 3D print with a Marvin again, it's going to erase what you did. So it won't keep that erasing. It's not a setting, it's an operation. Add platform, I don't recommend that one right now. I've used that in the past. It's not quite complete yet. But that's another one that's an operation-based function. Dilate first layers, yet another operation. So if I have a thin print and I want to expand, if I have like little tiny supports and I just want to expand the amount of area they have, I can just run that. And it's just going to thicken. It's going to thicken those. on the first layer. That'll just help you make it a little bit of a platform. You don't want to do it too much because SafFire does have trouble with flat areas, but that will get you started. And that's just an operation, so if you want to save it, you have to do save settings one of the entire print ones. Otherwise, it's going to be erased if you reload the 3D print. So it's not a setting, it's something that you execute. Find volume, you can just do that. Sometimes it takes a little while. These should be in microliters, so this should be a 9 milliliter print about. And you see there's a lot of voxels there. Plate level is one that you want to run before you print, so that'll automatically lower the plate. And before you run plate level, you want to just raise it up to slightly below the resin level. So you want the whole thing to be flush. The top of the build plate should be flush with the top of the resin level. When you run plate level, it goes down, hits the micro switch, comes back up. And the reason it does that is to know, number one, how tall of a print can you make, and number two, what should the focal distance be and the focal plane, because the laser comes out at an angle. So if you move the height, it's going to change in size. So it's got to know how to do the trigonometry to do that. But pretty simple. You just have to do that before every print. Jog motor is only for the large accessory. I'm not going to be talking about the large accessory much now. And these, you're just going to choose whichever one that you want to use. Settings menu's got quite a few things in there. Most of the time you won't need to change. Probably the one that you'll be changing the most, maybe the two that you'll be changing most, is the hollow bottom. I'm going to talk about the infill a little bit later, and I'll show you what hollow bottom means. There's also the neutral density filters. Those will be covered too, but just showing you the options now that you can choose whatever you have enabled, and it'll affect your powers. Like now it says 4 equals 8. If I turn that off, say 4 equals 31. The whole purpose of those is just to allow you to do really fine work. There's also a units menu. Just choose whatever units that you want to use. They're just for display. These will display, the Fahrenheit Celsius will display in the corner for diode temperature, and these will display down here as well as in printer control and on the LCD of the SafFire. Calibration is normally not enabled. You can just take a quick look at what's in there, but this is what I use to do factory calibration. And that's about it for the menu items for ProtoPart. ProtoPart stores 3D prints as 3D images, because the SafFire is a little bit different than normal laser SLA printers in that it doesn't do a scan around the edge. There is a trace command that you can use to do that, but every piece of data is actually stored as a voxel. So it has a defined voxel for each one of these. So these voxels will all be on a certain layer. The dimensions in the X and Y direction are 676 by 258. This is my dual Marvin that I arrayed. And it also has a height, so there'll be 338 layers in the Z direction. And that will equal a 25.35 millimeter height at the 75 micron slice height. This is all stored as a 3D image. It's just a monochrome, just ones and zeros. So it's really more like a DLP printer in that way. But it's got a variable resolution. It doesn't have to be a fixed size. So it just makes the resolution whatever it needs to be. Now you can add a border to things. If you use border area, you do an import. You have a little bit of a border around it. And that can help for certain things. I'll get into that later. But more or less, you don't usually need to use that. More or less, it's just whatever size it needs to be is what it'll be. This is a little bit larger, 400 by 320 for one Marvin. The maximum resolution is 4608 pixels squared. Now that will be changing to 8192 with the next high-speed version of the SafFire. But there's not many situations where you need 4608 pixels square anyway. Maybe if you're doing something really fine, maybe some really precise jewelry, but that should be enough for pretty much what you need to do. And that it will be quite slow at that resolution, but it can do some tricks. It can skip certain lines. If you're painting across, say you're painting like this, you don't need to paint all this stuff. Whereas a DLP printer will need to print the whole area. So you can skip that in the SafFire. So it does speed it up a little bit. So smaller things, fewer things on the build plate will be faster to print. And of course, lower resolutions, higher voxel sizes, like 75 as opposed to 37.5, will also be faster, quite significantly. So these are all just stored as a series of images in ProtoPart. That's pretty much it about 3D images. I want to talk a little bit about settings files. Settings files are a very important component of ProtoPart. They're a feature that you'll use quite often to work with it. And they will basically save all of your settings for a given print. So let's say I have a print that looks like this. This is a hollow.marvin. You can see the hollow bottom option is on. I'll talk about that a little bit more later. It's going to be that one, but that allows the resin to flow down there. So let's say I do this print and it turns out really successfully. So if I want to save the settings for that, I have a couple of options. I've actually got 4. This is for laser engraving only. I got printer setting and control, unprocessed, and process entire prints. So processing is pretty much synonymous with the recalculation step. Let's say I want to save everything. I'll just do that. And if I reopen that, the only thing it needs to do is just measure. It just measures the wall thickness there, because that's not stored in the file. This is an example of what a SafFire looks like, by the way. All of them are just .saf on the end, but they can have different contents. This one is an octagon. It's got an image, extruded image in there. This is an unprocessed. It has a base images only. They're all the same because it's an extrusion. There's 100 layers. You don't need to edit these, but the option is there if you want to. There's also the unprocessed option in Save Settings. So this will make it so you have to do the recalculation later. So if I reopen this, you'll find it's got a rehollow now. The benefit of this is you can make the file smaller. The compression's quite good. It's actually a custom algorithm I came up with. It's a run length encoding, base 64. But the files could be quite large. If you have a large, figurine character, then it may be, 50 megabytes. So if you don't mind waiting for the recalculation, you can just save unprocessed and just do that later. There's also some other options. There's printer setting and control and printer setting only. So I'll talk about what actually gets opened and saved with those. Now, if you do these last two, they will include this one. So everything's like just increasing here. Everything here includes everything before it, basically. So if you save settings only, it will save basically all of these, except it's going to leave off these first 5. These are specific to a printer serial number. So when you buy a printer, I send you a file like this, and it's got the X scale. This is for laser. Actually, it's got X scale here, skew, Y skew, and Z scale. That's just for large accessory only. So the reason for that is that you can scale the print separately with the SVG importer. You can scale it in Slicer too as an STL. So you really want these to correspond to each individual printer. That's why you don't really want these to get saved or opened in settings files. But if you do printer settings saving, that does everything in here. It also will do the resin shelf, motor delay, and settle delay. And finally, it'll do these, and it'll do all that. So it'll reload whatever filter that you need to use. Last but not least, it'll do the accessories. Now, if you do printer settings and control parameters, which is one I like to use quite a bit, pretty much saves everything that you need besides those defaults. It'll save everything in here. Some of these are calculated. The size X and size Y are calculated from the resolution and the voxel count. You can move this around and it'll save all your rotations, all your positions with those. It'll also save the thick layers. And that is pretty much it for the settings. There's definitely something you want to use quite a bit. So if you have a successful print, record it. At least do this one, That way you have a record of what worked. I talked a little bit about recalculation. I want to go in a little bit more detail about what that specifically is. So normally you'll have a solid print, and the recalculation is really split into two different parts. It's split into the measurement part, which will measure the wall thickness. In this case, it's going to be pretty thick and really thick there. And the reason it needs to know that is it adjusts the settings for the settling time. So that'll be that, and that. I'll go into more detail on those later. But that's why it needs to know the wall thickness. So it'll pretty much always do that. Even if you saved a process print, it still needs to do the remeasuring. But the longer portion will be if you want to make it hollow or if you want to add a lattice. So I'll just add an example, a little bit larger lattice. Now it'll go through multiple steps. These steps will change depending on what you're doing. There's more advanced options, but it just needs to do the hollowing and intersecting for this, and you can see there's a lattice inside now. Now I have hollow bottom enabled. If I turn that off, it'll recalculate again. Generally, I don't recommend printing with that off, because the purpose of this is to allow resin to actually sink underneath, to be able to, it just acts as a drain hole basically. But if you for some reason wanted to do that, like maybe if you're using Alt Hex, which I'll talk about a little bit later, you may want to turn that hollow bottom feature off, so it'll just automatically recalculate. You can abort, and if you go in Control, it'll do it again. You can abort again, but you won't be able to run job until you actually fully finish that, and you also won't be able to do the process save, because it has to know processing is synonymous with recalculation. The other thing that it might need to recalculate is for this. So it'll do more calculations for that. And you can abort that if you want, or you can let it go. That's pretty much it for recalculation. There's lots of different options in here, and I'll get to those later. But it'll pretty much need to recalculate for any kind of, other than just completely solid print that you might have. But you just wait for it. It's a multi-threaded process, so it should be pretty quick, but it may take up to half an hour for really large prints. But it should give you a good progress output like that. So just something you just have to wait for, something you have to be aware of. Two of the terms that you'll see used regarding the ProtoPart software are Infill and Outline. These are going to be a little bit different than what most people are used to for 3D printers. These settings are pretty much specific to the SafFire. The whole purpose of Infill and Outline are to separate the interior and exterior parts of a print. So the way that this will actually print is it's going to do a pass on the black and the pink. The pink is an overlap, so it's done both. But it'll do the black and the pink at a larger size. You can see how it's a little pixelated there. It's actually a 3 times size here. So it'll paint that first, and then after that it'll go and paint the blue and the pink. So we'll print it in 2 different passes, and you can change what the fill methods are. So you can do like a outward spiral from the center, which for a Marvin is something good, particularly when you get to the body. So it'll just prevent shrinkage. Since it starts at the middle part gets stronger. And then after that you can do like a horizontal or vertical scan over the rest of it. And the way that you actually turn these on is by this setting here. So if this is 0, it doesn't matter what this one is. So if it's 0, everything's off. But if it's 1 or larger, it will use the Infill and Outline. You can change the outline thickness. If I want it to be really thick, I'll do 10. It takes a little bit long to calculate, so I'm not going to demonstrate that now. Let's just do a 1 and a 5. And this will be with a solid print. You can choose different values here. It's not important. They don't really interact. Oops, I think I made that 0 accidentally. Let's try that again. 1. So that 1 means that the actual voxel size on the inside is going to be a multiple of 1. So it'll still be 75 microns. So you see it doesn't have that pixelation that it had before. And on the converse, if I make it a lot larger, you'll see it'll look pretty different. So it's really pixelated now. So you can choose what you want that to be. A lot of the time, I'll just use 2 for that, which would be 150 microns. If I'm doing 75 for the main print, then I really don't want more than 150 for the interior, because 150 is close to the limit of what the SafFire can do. You definitely need to use a lot of defocusing if you were doing one that large, because you'll get a lot of lines in the print. The laser spot's so small that it doesn't actually connect. So you can use these, and so what will happen is the infill, which is the black and pink part, will be printed with these energy settings, power and time. And the fill methods are going to be here. So all of these down here with a slash in them mean infill and outline. And you can actually see different power ratings. These power ratings are not quite right for this. It wouldn't be practical, but just to show you what it looks like, it would be that. So you have to have a lot more. If you're doing a larger size like that, let's do 2. Let's do some reasonable values here. You're pretty much going to have that at 4 times the amount. That way it'll actually be a little bit softer, because it goes with power. The energy required per dot goes with about power of 2 1/4 or so. So you can see it's actually exactly the same there, 34, 34, but it will be a little bit softer on the larger voxel size. And you can see what the voxel sizes actually are. So it'll say 150, 75, 150, 75, and then the height 75. So by making it larger, it just speeds up the printing of the inside. It allows you to do it softer in that way. It's pretty much the main use of that function. You can also do image dilation. That's a separate setting I'll talk about later. But that's pretty much it for the infill and outline. Most of the time I'll give you settings files that have that enabled. It's not necessarily something you would want to be experimenting with that much. Most of the time it's not necessary. If you're doing like a really high quality print, sometimes you might want to separate. Like for the lattice, I like to use it. I usually use a 2 and anywhere from 4 to 6 on that. Because what happens with the lattice is that, let's show you what that looks like. See, it's going to do quite a few operations now. What happens if you try to print the lattice all in one go, it'll pull on the edge and it'll give all these ripples on the side of the print. So what I do is I print the lattice separately, and a lot of the time I'll use this for a 37.5 micron print. I'll use a 75 micron infill size, and so it'll do maybe a horizontal scan or a vertical scan or an outward spiral, anything that you want it to do, depending on what you choose here. Usually I just use like horizontal, so it'll just go that way, and then with the infill, and then back again with the outline. And because it paints it in 2 different steps, you don't get that pulling on the outside as much. You get a smoother finish on the outside. Looks pretty good. And it being softer on the inside does help that too, because if you print it all in one pass, you wouldn't be able to change the power of what the inside was. So that's pretty much for infill and outline. Definitely ask me if you have any more questions about those. One of the options that ProtoPart supports is doing hollowing. Hollowing doesn't necessarily mean that the inside's going to be completely hollow. It's just a way of splitting the inside from the outside. So we talked about the infill and outline here. These work, I'm going to turn these off, these work only on a horizontal level. Though there is some polishing to try to clean it up due to the larger voxel size there. These 2 settings work on a 3D level, so vertical and horizontal, just all directions. So let's do a simple hollow here. Let's set a reasonable shell. And we just wait for it to recalculate. You can see it's a pretty thin shell. So the shell, if I have 5 here, that's going to multiply by the X and Y size. Generally you have these the same, so I think it just averages them. So you'll have 375 microns, or 0.375 millimeters. That's a little bit thin, but you kind of get the point here. It just totally makes that shell. Now we have hollow bottom on now, which is generally what you want to use. If you turn that off, as we mentioned, it's going to cover up that. We generally don't want to do that for the hollow or lattice functions, because you won't be able to get that resin out. The point of printing hollow is that larger areas, flatter areas, are hard for the SafFire because it's a top-down printer. Bottom up has some trouble with that too. The other thing is it saves you resin. But because of that, you want to have some drain area, some drain hole for that resin to get out of. So you generally want to print with that hollow bottom setting enabled. There are some different situations, however. There's other options. So here's a lattice. Let's make that a little bit thicker. So it's sort of doing the same hollowing, but instead of putting nothing there, it's putting a fixed lattice pattern. Now the pitch of the lattice is determined by this. Now most of the time you want to use 7.5. Now just to make it consistent, I'll put that here too. The reason to use 7.5 is because the plate, build plate, has holes that are spaced at 7.5 millimeters. 7.5 millimeter centers, actually 4 millimeter diameter holes. So if you look at how that actually looks, we'll remove our rotation. This model's a little bit hard to see because it's smaller. Let me go in the middle. It'll be a little bit easier to see. Just want to make sure that lattice won't fall through. But what happens is the lattice, let's go back to the beginning here. The dots will always fall on the solid part of the build plate. And let's do another kind of Marvin so we can see. Let's open a different kind of Marvin. I have a 200. Let's do a 200, 125. That way we'll be able to see a little bit better. Of course, it's going to take a little bit longer to hollow. There you can see a little bit easier. You can just adjust these guys so they're around the hole. But since the pitch is the same, those little lattice dots are guaranteed to never fall through a hole. And the outline is, because it's so continuous, it's generally not a problem. One thing to note about this Marvin is it does have an unsupported area. Usually, I've actually removed it in this SVG file. Usually it has a little unsupported area right there, so it technically would need a support. This one I've edited manually to remove that. The lattice works pretty well, and as I mentioned before, you can combine that with the infill multiplier. So you can probably set that to 2 and set that to like 5. And this way you'll get 2 separate passes, so you can make a softer inside. It just prevents rippling on the outside. So we'll just scroll through that. That's a pretty workable print there. That'll look pretty good. There's other options to use as well. Let's say you want to do some stuff solid. In that case, there's some different options. And these are called alternating polygon infill modes. There's 3 of them right now. There's grout hex, alt hex, and alt square. I'm going to turn this off to speed things up. Maybe just turn that down too. So this will be a grout hex. This will use, so yeah, just grout hex will use that, and also these. I'll talk about those in a minute. Let's do a grout hex. Again, it still uses that pitch. So imagine a bunch of hexagonal tiles and a bunch of grout that goes in the gaps. That's pretty much what this is doing. And the reason for this is you don't necessarily want to cure the whole layer at once because it shrinks more that way. And you'll get some problems with warping in the prints if you try to do that. Grout hex has a period of 2, so it repeats every 2 layers, and I'll show you that in a minute. So this is a 30% size. See, it just keeps repeating like that. So the black, anywhere it's black, that's where the laser is going to paint. It'll just be off in the white areas. So the outline stays pretty consistent, but it just alternates those on and off like that. And another thing that does, it helps reduce the bulging because the resin can kind of flow through those little gaps. It doesn't work as well on this one, but it will help your shrinkage. A lot of the time I use the alt hex. That's a little bit different. That has a period of 3. So instead of using grout, that will use 3 different sets of hexagons. Now that does not use the wall setting. I find that 30% tends to be a pretty optimal setting for the wall thickness for the grout. And this is what the alt hex looks like. Generally you'd want to do a smaller one than this. This is 7.5 millimeters. Generally you want to do like 2 to 3 millimeters, something like that. 3 is probably good. So you see it every 3, 1, 2, 3, 4, it repeats. So it's just painting that one. What that does is the shrinkage is just limited to this little section. And this is great for the bulging prevention. There's also another one just called alt square. Let's turn our pitch down a little bit here. Let's make it like 2.5. Both. Sometimes for alt hex and alt square you may have some adhesion problems. So you may have to actually use an infill multiplier of 2 in order to be able to get your power up high enough. So you try to turn your power up high here, it's going to be too hard. And it's going to shrink a lot. So that's one of the reasons you want to turn the voxel size up. That way you have actually a thinner section. You can print it nice and soft that way. This helps significantly for a solid part. So this part, even though it looks like this, it'll actually be solid. So this really, there's only a quarter of the space being cured. So technically it would be a quarter as hard. But you can adjust that as you need to. But this is great for flow because it has lots of extra little paths for the resin to flow through. So I use those for doing solid. A lot of the time in the large accessory I use those. The small, I don't use them too much because I'm generally not doing solid things. But in the large accessory it definitely helps, or any accessory with a wiper, it will help because the resin can flow between there and it'll prevent the wiper from sticking or colliding. There's some other methods that are maybe a little bit more like FDM. There's triangle. I generally use the lattice instead of those because the triangle one may trap resin. Again, you probably would want to use a 7.5 millimeter with that triangle so you can escape your build holes. Though it won't line up perfectly because build holes are on a rectangular matrix. Well, that's pretty much what that looks like. Again, you will have quite a bit of trapped resin with that. So this may be better for an extruded part. And here's for completion the square. So this is just it's actually a tilted diamond-like shape, just totally vertical infill mode. And finally the totally vertical hexagon. And these will all use that wall thickness factor. I'll show you what that looks like. And again, these are some hexagons, so just totally vertical. So if I want to include, or I want to increase the pitch of that, I'll put that back to 7.5. Let's say I want to crank that wall down. I can go all the way down to 5. It'll be pretty thin then. Now, some of these settings may not be, perfectly printable, but your mileage may vary. You can, I have wide range just so you can adjust them as you need to. This one, like the others, again, will have the trapped resin, but it may be good in certain situations. So you see a pretty thin wall there, and obviously if you increase that setting, you'll have a lot thicker wall. The recalculation can take a while sometimes, particularly if you're doing these two. But that is pretty much it for the infill modes. The lattice is definitely a nice one, because that's gives you good support inside. So one of the problems is if you hollow an item, you'll have unsupported areas inside that you didn't have if it were solid. So you have to have something that touches that, something that comes from below to grab onto that. And that's really the function of the lattice. You can print it part hollow. If you design it correctly, you can certainly do that. But the lattice gives a nice, stronger structure to it. So that's why I recommend using that. But yeah, hollow will work in a lot of situations, and sometimes you might want to do it solid. So that's pretty much for the infill patterns. Since the SafFire mainly uses a laser and galvanometers, it has to have some kind of a fill method in order to paint all these individual dots. Now, as we discussed before, it doesn't act like some of the other laser SLA printers in that it actually will do a vector scan around the outside. It actually does a dot-by-dot scan. So it's really painting an image on top of that surface each time. But you can choose how you want it to actually do that kind of fill. And the way that you do that is generally through this menu. So these will be the main three options. This is a square spiral. That's just really the easiest way to do it with an image. Generally it'll go from the inside outwards. So we'll start on the inside and just keep going out. There's horizontal and vertical. Horizontal will be referenced to this one here. So if you have a rotation, say you rotated it 45 degrees, it'll start down here, go over, come back, and go over like that until it's all the way done. Vertical will do the opposite. It'll start at the top here, go over like this. And so it's dependent on this image here. So the rotation, it'll completely rotate all of the operations that you're doing. And of course the offsets will do the same thing too. The spiral is good for if you want to print a solid object. You can actually separate that out in an infill, an outline, and you can just set the infill to a spiral. For example, you do something like this where you do a spiral plus burst on the inside, and that way it prevents some shrinkage. You can also turn the power down for that. But the spiral will leave a little bit unpretty finish. It'll leave like a pyramidal shape. And that's not generally something you want for the outside, because you will see that. So for that, what we'll do is the horizontal scan. So this would, for the infill, would do a spiral on the inside, and then it would come across again and do a horizontal. So you'd have a little bit more sloppy inside, but you're working well with that shrinkage factor. And the outside can be really clean with the horizontal scan. There's also another way to change some of those fill settings. That's going to be through here. I normally leave this one on spiral scan plus burst because I use it for the thick layers. I find that one works well for the thick layers. The slow layers are anything you want them to be, but right now I have it set to T. So T will just include any of those thick layers. Let me go in printer control. So right now I have it set to 2 thick layers. I think I hit cancel, so let me do that. Okay. You can see it tells you the actual fill method here. So whatever these two are, it's thick. Sometimes if I do an Eiffel Tower, I'll do a spiral scan for most of it, but at the top where I have some fine details, I'll do horizontal plus bursts, and then it'll be, you know, whatever the higher number is. This doesn't have that many layers, so we can just do 200 to last. And that way, everything above 200 all the way to the end is going to be that horizontal scan. There's also F for the slow layers. I'll talk a little bit more about the slow layers later. But those are ones for the regular, and these are ones for the slow. So that's pretty much it for the fill patterns. You don't have to worry about those too much. Most of the time you'll just be using this one, to be honest, the horizontal and the vertical alternating. So what it'll do is just it'll alternate every other layer, horizontal and vertical. You can choose bidirectional. Bidirectional just means for horizontal it would start up here, come over like that, and on the next layer it'll start actually in this corner and go back up. Just maybe it'll give you a little bit smoother finish, who knows. And there's also serpentine. I recommend leaving serpentine on. If it's on, it'll come over like that for horizontal, go back, and it'll just keep painting it. It makes it a little bit faster. So if you turn that off, it's got to go over here and then actually turn the laser off completely, return, and go back. So I do prefer to leave that on. It's slightly more stressful on the galvanometers to have it off. The only other fill methods worth mentioning are some of these that are just the pixel based. I generally don't use those for 3D printing. There may be some circumstances where you want to use them. The trace is sort of like the traditional SLA printers where it goes around in a circle, but usually I want to use that for laser cutting because it's good at following a path. So it's usually quite slow, so it's generally not something you'd use for 3D printing, but it's there in case you need it. Flood fill is pretty much what it says. It's like in a paint program, it'll just pick a seed and just keep moving outwards. So we can put those back to T, and that's usually how I have it set. For symmetric parts, sometimes like the octagon test, I'll do the spiral for the whole thing, but it doesn't necessarily leave a perfect finish, so I generally just leave that at that setting there. Now sometimes the bursts may run into the edge, so you may have to do the vertical if you have a 0 degree. That way you get a little bit more edge. Let's say you're printing a big bracelet, something like that. We can imagine what this would look like. Let's make it a little bit bigger there. So if you're printing something a little bit larger, there's not enough room sometimes for the galvanometers to get enough room to get running. So you need that extra gap over there. It's a little bit more complicated to explain, but it'll tell you when you run the job that you'll need to change it to vertical. Of course, if you're doing a 90-degree rotation or a 270, then that'll actually be the opposite, so it'll be the horizontal. But pretty much most of the time you'll just be able to leave it at this. That's pretty much all for the fill methods. One of the very important features of ProtoPart are the energy settings. This is something that you definitely will need to change from time to time, particularly if you're printing with different sizes. Let's go ahead and load a 75 micron Marvin. Just simple like this. Let's turn off our hollowing. Let's just do solid part. Let's put that about 5, like that. So I generally recommend just a little bit more than this energy density. Let's turn that up a little bit. The energy is going to be equivalent for each individual dot. So these actually set the laser diode power. You can have different levels. Yours may look different. These are all calibrated, so it's calibrated for each machine. So you have to have the machine plugged in order to get the proper values to show. It will show something fairly close. But in order to get those to be really correct, you have to have actually the machine plugged in while you're using this dialog. And I call it energy because it's really a combination of power and time. The time, let's assume we're just using bursts. The time will be how much time gets spent at that dot. So it's sort of like an inverse of speed. So let's set those to 171. Let's move up. Not using infill now. Thick, let's use a little bit more than that. Want definitely a higher power or higher energy for thick. Now since I've moved this all the way up, I can't go in any higher power. So I've got to turn up the time because these actually multiply to give you an energy level per dot. So now, when you go in here, you'll see it's about 38 millijoules per square centimeter, which for something like fun to do deep black, it's going to be about right. Maybe even just slightly on the low side for that. And the thick power is going to change quite a bit depending on what you're doing. If you're doing something solid like this, first of all, you have to have some long settling times for that. But if you do want to do that, you can have a lower energy density for the thick because there's so much contact area. Whereas if you're doing a lattice, for example, if you have like a lattice like this, you're going to need a higher power because there's less contact area. So you just want to prevent it from peeling off. It's something you have to play with. It depends on how rough the particular build plate is that you're using. So different factors can affect that. Usually about 3 times as much power is good for that. Energy, I should say, is good for that. So it shows just depending on whatever one you're at. It'll change the dimension here for the thick slice too. Now if we do infill, you'll need to do something a little bit different. So let's say we want to do an infill. We still have our lattice. We can set each of those 3 powers differently. So what you'll see is you've actually got 2 different powers listed. Now this one's a little bit high now, so let's turn that down because you don't need that much for the infill. Even though it's larger, you knock that down by 2, that should be pretty good. And again, this one's proportionately less, even though it's about the same value, 38. Because it's a larger size, it's actually softer than it would otherwise be because it goes with about the power of 2.25 with the voxel size. So, and if you wanted to have the same hardness, you'd have to have it at 45, maybe a little bit less than that. So you're actually seeing what that particular energy density is for each one of those fill steps. So the first one is for the first infill fill step. Let's say you're doing a spiral B, spiral press burst. That first step will have those settings set to this. So there, internally, it actually sends command 29 to the laser diode. It gets back the temperature also when it does that. So it finds out the temperature. And this is calculated around the burst. I'll talk about the burst in a minute. So it'll set these, and for the thick, for the very thick layers never have any of this. So a thick layer is always 0 for this. That's why if you go down here, it's black. So if it's black, it means it's just an outline. On the rest of these, the blue is going to be outlined. The pink's just a little bit of an overlap. So the black will be the infill there. So I just disable that for the thick because you'd have to have a 4th power and it would just get too confusing. And the thick is pretty much sacrificial anyway. So one other thing to cover are the neutral density filters. So a lot of time I'll just be including one of these. So I've recently reduced the power of the machine, just to make it a little bit easier to use and for reliability reasons. So let's say you were doing something that was a really fine work. You want to use this. Let's load a Marvin. This isn't really a practical print. Let's just do this as an example. Say you want to do for some reason 15. It's going to take a little bit longer to load. And we can just abort that. It'll still show most of it. So you see the the energy is way too high here. So what you need to do, even if you turn this down, you don't have much adjustment range. But what I've done now is I've enabled that neutral density filter so that it just divides by 4, whatever this is. You can see these numbers have changed. So if I turn that off, this is how it was before. Oops, let me go to printer settings. So those are pretty high. So even if let's say I'm down around there. I've got just a really, really high energy density. So I don't have much room for adjustment there. Because I can't, if 44 to 51, that may be too high of a change. So what I do is I install one of these filters, and you actually have to screw the thing on. It's an ND4, it's called ND 0.6 filter. It's a 2-stop filter. It's a 49 millimeter for standard cameras. So if I do that, you can see that those energy densities have come down quite significantly. In fact, for this situation, you really need 2 of them. But generally, you wouldn't be printing at 15 microns in a resin that's that sensitive. So a lot of the castable resins, if you're doing jewelry, will require a higher setting there. Some of them may be up to 200 even. But that neutral density filter really allows you to get more adjustability on that range, and sometimes you may not be able to go down that low at all anyway. And you can see those would be fairly close for a castable resin. Maybe a little bit higher you'd be needing. Now with the Infill, we're doing a 30 micron. I don't recommend the Infill for jewelry applications. So we could turn that off. And if I turn it off, I usually just like to leave these the same. Let's check out see how our thick is doing here. Thick looks like it might be a little bit high, so we could turn that down. But that's the basics of using the neutral density filters. These will get saved in the settings file, so if you open and save it, it will restore and save what's in there. And you just have to make sure that if that's checked, you've got to have the thing screwed onto the machine. And just be careful with the thread. It's a little bit fragile, so don't try to tighten it too much. You can even be a little bit loose, because it'll be pretty hard to get off if you get it tight on there. So just be aware of that. One of the other things to cover are bursts. Bursts are specific to the SafFire. They're actually called digitized bursts. And so those are the names there. And again, it's really scanning a whole line at once. So for horizontal, it's going to go across the whole thing all at once, and it'll actually turn the laser on and off. It's called modulation. It'll just modulate that as necessary. So these things called burst periods. Now, at the very least, the time that you have to spend around one dot, because it's not going to be exactly on the dot because it's a continuous moving line, but per dot equivalently will be this value at the least. Now I'd refer to this as the numerator. So this is the amount of time that the laser would be on. Now let's say you're printing and you're experiencing some shrinkage issues. Resin's exothermic, so when you try to cure it with UV, it heats up. And the slower you can scan, the less temperature rise you get, because it has more time to dissipate throughout the part and through the air. So one of the things you might need to do is increase these burst periods. So I want to show you what happens. Let me load a simpler print just for demonstration purposes. The other one's a little bit slow. We can calculate, we can cancel that. Let's just make it solid. You can actually click calculate durations here, Now I'll show you the actual fill method. I just put it on 1 and I do alternating. It'll show me 2 seconds there. And this is maybe not a perfect example, but if I want to make that slower, I can crank that up, and it's gonna about double those times, which may make a difference. 2 seconds is kind of quick for something like that. Let's put these back to 0. So you really want to use that sparingly, but if you're experiencing a lot of temperature rise, that's definitely something that could help. The slow is just associated with the slow layers. So this is really the minimum denominator. So you'll have, for example, if I have 50 here, it'll pulse on and off. So it'll pulse, let's say I'm, in the middle here somewhere, it'll pulse on for 12.5 microseconds. And again, a microsecond is a millionth of a second. So it's running at 80,000 hertz right now. In the future, that'll be 200 kilohertz. So it'll be on for that 12.5, and it'll be off for at least 37.5. Now there may be some other reasons that gets longer. The main reason that would get longer is if you have that print really nestled up to the side, obviously still on the build plate. But if you have a really big print and it can't quite have enough time to speed up, because the galvos don't move infinitely, they have some limited limited range there. So it'll slow down the burst so that it doesn't need as much room to get started, and that will automatically slow down your burst. Let's see if we can demonstrate this. So we have that there. Let's do it. We're just doing this to imagine. So you see the horizontal is 4 there, whereas if I move it here, it goes down to 2. And the reason it's longer is because it's pushing that value up on its own. So again, this is the minimum denominator, but it can't necessarily go that fast if the print is too close to the edge. So that's the one reason you want to keep the prints fairly close to the center. The true center is, I think, about this far over, so you can imagine, the actual center of the machine is there. So this is really the best place to put it. You may get some nasty effects over here, so anywhere really in the middle of the build plate is the best for those, just to keep those bursts so they got plenty of room to start up and slow down. A little bit of a complex subject. You can certainly contact me if you have questions regarding this, but that's basically how the bursts work. Most of the good film methods will use those because they're faster. So, but most of the time you can leave these here. You're printing characters, you just do a lattice and you don't need to worry about it. And again, if you're doing a pretty large, like 100 micron print, you obviously want to have your filters off, and you want it to be really hard. You will have to crank up this because they will multiply together, but then you may want to turn this down. And again, that'll all show right there. That's pretty much it for energy. ProtoPart is pretty setting rich, so I want to talk about some of the options that you have in 2 of these main dialogues. This is printer control. As I mentioned before, the size X and size Y are automatically set. If you do extrusions, then you can change those. Generally, you want to leave the X and Y voxels the same size. So you generally don't need to touch a lot of that if you're doing, an SVG from an STL. The center X and center Y, you just move that wherever you want on the build plate. Generally, you just want to avoid things falling through the holes. With a Marvin, it wouldn't be too big of a deal here. Rotation can change that as well. Size Z, generally not something you need to change. It's just this number times this number. and it does not include the thick slices. So it's just something you have to keep in mind. If you try to print something that's too tall, it will give you a warning about that. Won't let you do it. The thick slice is just the first however many that you have laid down. It uses a different power setting. Generally I just leave that at 2 or 3. Sometimes you want to do a little more. If you want to do a sprue on a ring, you can turn that up pretty high, like 50. And that'll just get you a quicker time to do a sprue if you don't really care what it looks like. It'll have a little bit rougher surface finish. So it's got a higher power, but it'll work fine. But for most stuff, you just leave that at about 2. Resin shelf's a little bit more difficult to explain. It's going to be how much a layer influences the settling time, depending on how far it is below the level. So if I have like a really thick part, it's not really a great example on this Marvin. If I go to the eyes, I have a part here. Let me make this a little bit bigger. I have a part here where it's got a thicker section, so just imagine the whole print was just cropped off to that section. If I'm moving up, I don't have that anymore, so it's going to measure the thickness to be thinner because there's not that material there anymore. But the problem is that the resin won't settle perfectly because it's still underneath a little bit. So this gives you like a 1 over E or 37% factor where that's where it'll cut off. So if it's 1 millimeter above that, it'll only affect it 37% as much as it would if it's right at that layer. And of course it's going to measure for the layer that's one underneath what you have. The build plate is going to be considered infinite. So that'll use the maximum settling. So the settling times, and generally I just use that at 1 millimeter. It seems to always work fine there. The settling times, there's 2 different ones shown here. It's a motor and a settle delay. The motor delay will be when the plate will go down, it'll pull back with a pullback amount, and then it'll go up to a certain level. I'll show you that in a minute. And the delay in that last little section is usually about 10% of the distance, just coming up to the very end will be made by that. And the reason I don't go all the way up and then just wait is because that resin will get pinched off and it actually won't have the chance to flow off as easily. So I generally like to just come up very slowly at the very end when I'm moving the plate back up. If you're using something like 75 microns, you probably don't need that much, maybe like 3 for like a fun and do deep black. If you're using, something like 37.5, you maybe want to put that at around 6 or so. I usually keep these about the same. This settling is just after it's all the way up and not moving. How much to do? But these can get extended. So that brings me to the next. This is going to be printer settings dialog. While I'm on that topic, this is the maximum settling for those. So what happens is you'll have to remeasure after you change that. If it's set to 500, then if it finds an infinitely thick section such as the build plate, it'll multiply these values by 5. So it'll actually be 30 seconds motor delay and 30 seconds settle delay. Now the build plate's not the only thing, it'll increase it. So it'll measure the wall thickness. It has to know, of course, what the scale is. Since this is a pretty thick Marvin, you're going to be getting some pretty long settling times. This is going to be, about 30 millimeters across here. So it'll saturate this. So what happens is it'll take the measurement, it'll divide by that, it'll take it to that power, and then it'll crop it at this. It'll maximize it at that. So if I had, let's say I had a 2 millimeter wall, it'll divide it by 1. That'll be a factor of 2. It'll take it to power 1, which is still 2. And then what'll happen is it'll make it a 200% settling than it would have been. So those 5-second values, or 6 as they are now, those will change into 12. So it's variable because sometimes you don't necessarily need the whole settling time. If you just got a thin wall, you don't want to wait for it to do it that long. So it's a variable time. But that value also does something else. It changes the Z speed. So this will go down by the amount. So if you had a 2, it'll go down to 50. So the plate moves as follows. First thing it'll do is go down by the pullback distance. You can usually leave this around 2.5 for the fun to do resins. So it'll go down by 2.5, and then it'll wait for the sunken delay. Now again, this will also get multiplied by that factor. So if we're doing 500 and I have it at 0.1, it'll be a half second at the first build plate layer, and it'll be a half second if I have a pretty thick section. So it moves down by pullback. It waits for the sunken. The sunken's just so you don't have to go so far down. It gives you a little bit more height. So the sunken's just after it's down, how long it waits for the resin to kind of spill over the top of the print, completely cover the print. After that, it'll move back up, and it'll do that at that Z speed limit. It actually also moved down by the Z, but going back up, it will divide by whatever your settling percentage is, depending on what your wall thickness was at that level. So if you got something real thick, it'll go down like at 100%, but then it'll only go up at about 20%. Now, let's set this to be about 10. I usually like to leave that about 10. So the last 1/4 millimeter, so this is 2.5 divided by 10, or 2.5 times 0.1 here. That'll be the last 1/4 millimeter is what's going to transition for that motor delay value. So the last 1/4 millimeter will go this times whatever your calculated maximum settling. So for the build plate, it will take about 30 seconds to do that last 1/4 millimeter if I have it set like that. So the upshot is, if you want to do a thicker resin, or if you have something really fragile, you want to turn down that Z speed limit. For the slow zone, I leave that at 10. You want to do about a 1/4 millimeter. If you've got like a 5 millimeter pullback, maybe you put that even lower. It's something you can play with. I just don't necessarily know the optimal ones for these, but it's generally leaving it around that kind of value works pretty well. If you can't get a covering on the print, so if you have a large area and you can't get it to cover, then you need to increase that pullback. There's some other settings here as well. The scale factor. If you find your prints are getting a little bit too big or a little bit too small, you can change those. You generally don't need to touch the Z one. The Z should be quite accurate. That's just something you might find that you need to use. It's just there for completion. Generally, I print the octagon, and I generally give it out at 75 microns. So if you print it at 75 microns, and it should be 24 millimeters across. So if it's like 23, then you want to increase that a little bit on the X, whichever dimension it is. X is going to be across this way, and Y is going to be across this way. So you can just adjust, you can calibrate your printer. And you may need to calibrate for different resin levels, but it shouldn't really be more than 3% off, so it should be pretty close. But you can get really good repeatability if you do this. You really want to dial in what the size is. And of course, it's going to depend on resin. Shrinkage is going to depend on maybe even power. So if you really want good repeatable results, you'll have to calibrate that with whatever your situation might be. So we talked about those. The focus offset is something you might want to put negative sometimes. So for some of the figurines, I do actually all the way down at -10. And it gives a nice smooth surface. The power might need to be adjusted, but what it does is it focuses the laser further than it normally would. So it kind of blurs the dot a little bit, so it makes the laser spot bigger. But if you have it at 0, sometimes the prints will get fuzzy on the outside, and it doesn't really give a very good smooth appearance. I can provide some more examples of those on my website, just when to use that, when not to use that. It's generally safe to use 0. If you see the print breaking up, you may have too much of this focus adjustment. So I talked about the settling reference. The wiper is only for the large accessory. Both of those are only for the large accessory. We talked about the energy levels, and we also talked about those. The image dilation is just something you can use to increase or decrease. So a positive value will make it thicker. It's going to take a while, so I'll just do about 2 there. So it actually expands. You can see the margin got a little bit bigger. But if you put that down, it'll contract. And this is for just finally adjusting the size of things. You don't generally want to do it too much. But if you're doing like printing like a ring that has a mesh, you can adjust that by that. But so if you do 1, it'll make the difference by, in this particular example, by 150 microns. Because it's doing it on each side. So each one has 2 sides. So it'll take off one from that side, one from that side, kind of, if you have a square. So since we're doing, well, in this case we have 120 microns. It'll take, in this case, it'll be 240. I think I adjusted my resolution. There we go. Back to 75. So 150 for 1. Generally, I just like to leave that at 0, though. Support pitch is not something that's really implemented quite yet. I use that for the platform, but that part's not really done yet. The infill pitch, again, that just corresponds to whatever this is. For lattice, I like to leave it 7.5. For something like alt hex, I'd probably put that about 3 millimeters. And we talked about the wall thickness. And the slow layers, again, are ones that you can just pull out. I gave the Eiffel Tower example where at the top of the Eiffel Tower, I want to do just a horizontal scan because the spiral leaves sort of a not very pretty pattern. But the spiral is generally better for the bottom because it actually takes less time. Because for the Eiffel Tower, there's so much empty space in the middle, particularly at the bottom, so it can actually just totally skip that. So it's actually faster to do the spiral for that. So for that, if I were doing the Eiffel Tower again, I would have spiral here. Let me see how many layers I have. So like, let's say I did, 300 to L. And I would put that at horizontal. That way my last few layers, so you can see the fill method changes. It'll just give a cleaner appearance. And you could actually even do that for the Marvin too, for that little hook. If you wanted to do a solid one without an infill. Probably start it maybe right about there. For the slow layers, you can do multiple ones too. So you can have like 250 to 275. So that comes back on then, horizontal. You just separate them with commas. You can also do something like first 75. So that'll show horizontal all the way up, and it's inclusive. So it'll include 75, and then you'll go back to spiral, and then when you hit 300, again you'll go back to the horizontal again. You would also use the T. So if I want to do like the first few layers, I could do like a T to 10. And that'll just make it so that anything 10 and below, including the thick, is going to be that slow fill pattern. And we talked about these, and that's pretty much it for the settings. Again, all these are loaded by the let's say settings command. So generally I just like to leave that there and there, and good luck playing with these. Should be a lot of fun to use this system.